In this video, we're going to solve linear inequalities in one variable. So last week we talked about how to solve linear equations in one variable, and you'll find that this is almost exactly the same, and I'll point out the differences as we go. So to begin with, just as I did if this were an equation, using an equal sign instead of, in this case, a less than or equal to sign, I'm going to take 3 times x and 3 times 4, keep that inequality the same. A lot of people forget and turn that into an equal sign. Make sure that you don't. Keep the 4x, keep the minus 8, and then distribute minus 2 to get minus 2x and plus 2. Again, just as we would if this were an equation, we will simplify the terms on the right side, combine like terms, so 4x and minus 2x combine to 2x. And minus 8 and plus 2 combine to minus 6. In equations, it really doesn't matter if the x, or whatever your variable is on the right or the left. Typically, I find that it's easier to keep the variable on the left side in inequalities, which I'll explain when we get to the graphing portion. So I'm going to go ahead and subtract the 2x from each side. Remember, we always deal with the x's first. It's just better practice. 3x minus 2x is 1x, or just x. The 12 comes straight down. The inequality stays the same. The minus 6 comes straight down. And I just want to point out again that in MA 102, this step you don't have to show me. So as long as you're doing only one step per line of work, I can follow your work. From here, again, I'm going to subtract 12 from each side. So I'm going to get x as less than or equal to negative 18. So this is my solution, and if I weren't asked to do anything else, I would be all done. But I'm asked to graph the solution set and write the solution in interval notation. So 2 different things. And these are things that you may or may not have done before. So we're going to do a little bit of review. And that review is first in graphing. So when I'm graphing, and again, when you're graphing in ALEX, they'll already have a number line for you. I'm going to go ahead and sketch a very simple number line. When we're graphing, we need to keep in mind whether or not the value is included or not. Value not included. And what I mean by that is whatever our value is here, is it a part of the solution set or not? So if the value is included, we're going to have a less than or equal to, or a greater than or equal to, because that or equal to means that value is included. When I graph, then, I'm going to be using a closed circle to indicate that that value is one of the solutions. If the value is not included, I'm going to have a less than or a greater than. Notice there's no or equal to, which means I'm going to use an open circle, and that open circle indicates that we're going to use all of the values up to that point, but not including that point. So in this case, if I were looking at negative 18, and it's an or equal to, I'm going to put a closed circle at negative 18. Then I'm going to shade my graph in either the right side direction or the left side direction based on this inequality. So this inequality is a less than or equal to, meaning where are the values that are less than or equal to negative 18? Is it negative 19, negative 20, negative 21, or is it negative 17, negative 16, etc.? If you get confused, this is why I suggest that the x goes on the left side, because the inequality actually points in the direction that I should shade. So this is my graph, and it's going to go on forever to the left, which is the values that are less than negative 18, and closed circle on negative 18. The other thing, so that's all I have to do for the graph, and if you're doing this in ALEX, it's a very easy graphing tool. Use the question mark if you're not sure how to graph in ALEX. If I'm writing the solution set in interval notation, again, I want to just review with you the interval notation in case you don't recall that from other classes that we've taken. If I have open parentheses, so those are just regular parentheses, I call them open parentheses. Again, because this is where the value is not included. So it's kind of like when I have the open circle, that's why I call it open parentheses. If I have closed brackets, the value is included. And keep in mind, it's possible to have an open and a closed, or a closed and an open. And again, there's going to be two values inside of there, and whatever comes first is the least value, and whatever comes second is the greatest value. So really we're just saying from least to greatest what values are included in the solution set. Keep in mind, if we're using the open parentheses, we would include the infinity or negative infinity, always with open. So let's take a look at our solution set. Again, looking at the values that are included, meaning I could take any number less than negative 18 or exactly negative 18 and plug it into this equation, and the solution would be correct, or the statement would be true. So you could try it, plug in negative 100, negative 1000, those should all make that equation true. Keep in mind that this is going on forever to the left side, meaning there is no left bound, there is no least value, so the least value we count as negative infinity. So when I'm writing my solution, I'm going to write an open bracket and negative infinity. Again, open because we always use open for infinities. And then the right side of my equation, the furthest value to the right, is negative 18. And is negative 18 included? Yes, it is, because we have that closed circle. So I'm going to have a closed bracket. That's how I would write my solution in interval notation, and of course how I would graph it. Let's try another question where we have to do something a little bit differently than we would if it were just an equation. So I'm still going to start the same way. I'm going to take 2x minus 18, 3x plus 7, and my next step would be to get all of the x's to one side. So again, I'm going to choose to subtract the 3x from each side because I want x's on the left. Now some people don't like that, because if I take 2x minus 3x, that gives me negative x. Bring down the negative 18, bring down the positive 7, because obviously these cancel. And then I'm going to add 18 to each side. So again, I haven't done anything differently than I would if it were an equation until right now. I currently have negative x is greater than 25, and I don't want negative x, I want positive x. So there's a rule when I'm dealing with inequalities. If I multiply or divide by a negative, which is what I've done here, it's okay to do that, but this inequality is going to flip to the opposite direction. So greater than becomes less than. So again, I could have, at this step up here, chosen to subtract 2x from each side, and that would have given me a positive x, but everything would have been backwards, and I still would have had to end up flipping everything around. But this is my solution. X is less than negative 25. If I were to graph this, again, negative 25, negative 26, negative 24, open or closed, well, there's no or equal to here. That means I should have an open circle at negative 25, and that just means we're going to use all of the values up to negative 25, but we can't include it. And then all of the values that are less than. So again, because I put the x on the left side, the arrow points in the direction. If I would have done it the other way, the arrow would have been the wrong way. Just like last time, again, my least value would be negative infinity. So open bracket, negative infinity. Right side is negative 25. And again, because it's not or equal to, that's also an open bracket. Let's do one more together. I'm going to go a little more quickly on this one just so that this is not a 30-minute video. So 9d plus 36 is less than 6d plus 24 plus 3d, just using that distributive property. Let's do a little bit of simplification. On the left side, I get 9d plus 24. Notice I'm going to subtract the 9d from each side, and when I do that, something interesting happens, and I get 36 is less than 24. So just as we did before when we had if it were true, it's all real numbers, and if it were false, it's no solution. So looking at this, 36 is in fact not less than 24, and because that's the case, this is going to be a no solution. So do I have to give a solution set? Well, my solution set is the empty set because there is no solution. Sorry, do I have to graph it? There's nothing to graph. So it doesn't matter what values I put on here. There's not going to be any circles or any lines or anything. There's no graph. Interval notation, there's no interval notation because there's no answers. Okay, one for you to try. I know I was kind of mean. I gave you a fraction. I think you can handle it. Press pause. Use that fraction clearing technique we talked about. Multiply everything by the least common multiple. Solve for x, then press play to see how you did. So again, I'm looking at the LCM, least common multiple, or least common denominator, I guess. I'm going to take everything here times 4, just because I don't want to deal with fractions. And you don't have to do it that way, I just find it so much easier. So this gives me 4x is less than, these 4's cancel, so I get 2x plus 1. This 4 reduces, and I end up with 2x. So here's my new inequality. No more craziness going on. I'm going to combine like terms. 4x is less than, and notice here I get 4x plus 1. Again, good idea to get the 4x's out of there, and we can see again we're going to end up with something a little bit crazy. 0 is less than 1, which happens to of course be a true statement. So if I were to graph my solution set, it would literally, and it doesn't matter what numbers are underneath, it would literally be everything is shaded because I can plug in any x that I want, and that is true. If I were to write the solution in interval notation, the furthest value to the left is negative infinity, the furthest value to the right is positive infinity, and so it's going to look like this. You might also see this again written with that crazy R that means all real numbers, but that's my solution is all real numbers.